We all know AI is getting crazy powerful, right? But here's the thing. Can we actually trust it? Today, we're going to look at a totally different way of thinking about AI reliability. What if instead of one giant superbrain, you built an entire team, like a whole office of AIs with specialists, fact-checkers, even a project manager? Yeah, it's a cool idea. Let's dive in.
So here's what we've got on tap. First, what is this Universal Cognitive Engine? We'll call it the UCE for short. Then we'll meet the team, the specialists doing the work, and crucially, the fact-checkers keeping them honest. After that, we'll look at the boss, the master orchestrator, and then we'll pull it all together to see why this whole setup really matters. Okay, so let's get right into it. What is the Universal Cognitive Engine? The easiest way to think about it is, don't think of it as a single genius AI. Instead, picture an entire company. It's a huge shift in thinking, right? We're moving away from this idea of one giant brain that has to know everything and moving towards building a whole organized team where every single member has a job to do. So the technical term is a multi-agent system, but let's stick with the office analogy. Imagine the best, most efficient office you've ever seen. You've got your top-tier coders over in one corner, your brilliant researchers in another, your math wizards, you get the picture. But, and this is key, you've also got a whole quality control team whose only job is to double-check everyone's work. And running the whole show? That's the project manager, the orchestrator, making sure every single task goes to exactly the right person.
And really, this all boils down to the one question that everyone in AI is trying to answer right now. How do you build an AI you can actually trust? Not just one that's powerful, but one that gets things right consistently. And this UCE architecture, well, it's a pretty fascinating answer to that question.
All right, so let's meet the team. The whole philosophy here is specialization. I mean, think about it. Why would you want an AI that's just okay at a bunch of things? A jack of all trades, master of none. Instead, the UC builds a roster of genuine experts. Each one is a master of its own domain.
And just look at who's on this team. It's pretty diverse. You've got a reasoning agent, which is kind of like your big picture strategic thinker. Then you have your workhorses, the code agent and the search agent for getting things done. And then you have the heavy hitters, like the Python compute agent. This thing is a beast. It can handle some seriously complex math, all inside a super secure environment.
Now, what's really cool is that these agents don't just think. They have tools, specialized tools for their specific jobs. So the search agent, naturally it uses Google Search. But check out the Python scientific tool. This is so much more than a calculator. It's a secure sandbox, a safe little playground where it can run really advanced Python code for stuff like linear algebra. But, and this is so important, it's completely walled off from doing anything dangerous, like touching your files. So this isn't just about making the AI powerful, it's about building safety right into its DNA.
Okay, so a team of experts is great, but that's only half the equation. This next part is where the UCE architecture gets really smart. The absolute secret to making it reliable? No one, and I mean no one, works alone. For every agent that does something, there's another agent dedicated to checking its work.
Just look at this example. Let's say the math agent solves a tricky problem. It doesn't just send the answer out. No way. First, its work gets passed over to a math checker agent. And what does the checker do? It solves the exact same problem, completely independently from scratch. If the answers don't line up, bam, it gets flagged. It's basically a built-in, automated peer review for everything the system does. Let's make this super concrete with a coding example. You ask for a function in Python. The code agent gets to work and writes it. But, and you're probably sensing a theme here, that code doesn't go straight to you. Nope. It first goes to the code tester agent. And this tester isn't just skimming the code, it's actively designing little tests for it, asking that crucial question, does this thing actually do what it's supposed to do? If it passes, great, it gets approved. If not, it gets kicked right back to the code agent with a note saying, here's what you need to fix.
And you'd think that's enough, right? A solver and a checker. But no, there's one more layer, a final boss of quality control, if you will. It's called the Critic agent. So after the specialists have done their thing and the checkers have checked their work, the final polished answer goes to the critic. And its job is to be the toughest boss you've ever had. It looks at the whole thing and asks, is this logical? Is it complete? And most importantly, does it actually answer the user's question? It doesn't make any changes itself. It just delivers the final verdict. Approve or revise.
Okay, so we've got all these specialists and all these checkers. It's a pretty big team. So who's in charge? How does a request know where to go?
Well, that is the job of the master orchestrator. This is the central brain, the project manager for the whole operation.
And let me be clear, this is not just a simple traffic cop waving requests through. The orchestrator is incredibly smart. I mean, look at this. This is an actual instruction from its programming. It knows that for linear algebra problems, it should probably use the reasoning agent. But if the user says something like run Python, it's smart enough to know, this one needs to go to the Python compute agent. It's not just a switchboard, it's a real decision-making engine.
So what happens when you put it all together? You've got this team of specialists, all managed by one super smart orchestrator. The result is an assistant that can do a ton of different things: write code, plan a project, do complex math. And you can trust the answers because you know every single step was verified along the way.
But here's my favorite part of the whole system. It's a single rule, written right into the orchestrator's instructions. Never mention tools or internal agents in user-facing text. Think about that. All of this incredible complexity we've been talking about, the different agents, the checkers, the tools, it's all designed to be completely invisible. From your perspective as the user, you're just talking to one single, incredibly smart and reliable assistant. All the hard work happens behind the curtain.
Okay, so let's zoom out and look at the big picture. Why go through all this trouble? Why build this whole complex team of AIs when you could just throw all your resources at making one single gigantic model? What's the big payoff here? It really comes down to a very simple but really powerful idea. When you take specialization, getting the right expert for the right job, and you combine it with verification, checking the work every single time, the result is reliability. You get a system you can actually trust.
And the benefits are pretty clear, right? First off, you get way higher accuracy because everything is being double-checked. Second, the system's more versatile. Need it to do something new? You can just add a new specialist agent to the team. And here's a huge one for the developers. It's so much easier to fix when something does wrong. You're not trying to figure out what's broken inside one giant mysterious black box. You can pinpoint exactly which agent messed up and fix just that one part.
So in the end, an architecture like this really makes you think about the future of AI. Are we just in a race to build one single all-powerful superbrain, or is the smarter path, the safer path, to build something that looks more like a smart, collaborative team of experts that we can actually understand and trust?